Hello, this is team number 39, and the project that we have developed is a multi-level traversable wheelchair with optimized route navigation. Here are the topics we will be going over.
So, an issue or group identified is how difficult everyday navigation can be for those with physical handicaps. According to the CDC, over 12% of adult disabilities involve mobility. With buildings growing larger and interior navigation becoming more complex in everyday locations, we chose to address this issue by simplifying the entire process. Our solution is a wheelchair capable of smoothly climbing stairs while displaying the optimized travel routes. The vision is to have these devices readily available at all locations that require complex travel.
Next, we have the concept model. Utilizing SolidWorks, we were able to modify an existing wheelchair by adding treads to the bottom, which can be stored underneath if they are raised above the ground. Next, we have a deployed mode, which will lower the treads to the ground and allow for stair traversing. Finally, there will be a digital screen built into the armrest that will house the routing software we are using. Now we are going to talk about the hardware and software involved. The hardware we will use include the electric-powered treads and sensors that detect when the user is moving. However, we will be focusing more on the software side, which includes an app that will allow for the mapping and planning of routes and algorithms with data gathering and mapping.
So, in order to consistently and accurately find optimized routes within various indoor facilities, we need lots of data on these buildings. The main source of data collection we hope to employ is through a partnership program with various companies in which will supply their built floor plans. Alternatively, crowdsourcing data through 360 AR mapping will also be used to provide additional images. These images will be used to calculate distances between various locations in each building, and which will be used to calculate the optimal route that the user will take. We'll discuss the algorithms used to calculate these later. Going beyond just being a wheelchair accessory, we designed a simplistic and function-driven UI that will be easily integrated in the iOS and Android ecosystem. First, the homepage will show the building. Next, the form will be filled out by each user when they want to generate a route, and the last image is what will be displayed.
The algorithm that we decided to use is a modified minimum weight Hamiltonian cycle. This will determine the shortest amount of time needed to travel to all locations introduced in the route. Each node within the algorithm corresponds to the location with a predetermined time cost from node to node, accounting to factors such as traffic, stairs, and other hazards. Here we have the code of the algorithm. In this example, we have manually inputted values into the matrix. In the final design, we will integrate this into our app using user-submitted data to replace the matrix values. In the main, we initialize the matrix of values representing the node locations with 1, 0, corresponding to the path needed to take from node 1 to node 2, which is 10. Next, we will initialize additional variables to call the function. The function first checks if the final node is reached. If so, it chooses a smaller one and recursively calls itself until it finds the route that takes the least amount of cost.